All right, so before we get into the programming, I want to know about what are your goals and what do you hope to get out of these sessions?
Um, I like you see, I don't know nothing about programming and coding, but I want to learn bioinformatics, so I need to learn some basics in Python for this. So I just need the basics.
Okay, cool. Okay, one thing I will say though, we're not using Python. We're using a different
Mhm.
language, but it will transition you to Python. Okay.
Yes,
All right, this
I
language is designed for
understand this.
beginners, and it'll be hopefully a better learning experience. To get started, could you add two numbers for us here?
I have to write some numbers.
Yeah, add two numbers.
Two numbers, like 1 and 2.
Yeah, and now let's add them, but with the computer.
Um, uh,
So how do we add two numbers?
okay, so I know
Ah,
something like this.
so okay, we don't need to do that. Let's just stick with numbers for now.
Okay, but
Yeah, let's keep it
can I
simple.
just 1 plus 2?
Yeah. Can we delete line three? Let's just keep it clean.
Yes.
Yeah, line three. Actually, no, I'll delete for you. Okay. All right, let's run
Yes.
it. Do you see it?
Okay.
We see three?
Yes.
Excellent. Okay, congratulations. You've just added two numbers. So programming is like using a calculator, which is unsurprising because calculators are computers. Okay.
Yeah.
Can you add a third number in there?
Um, oh, okay. And then
Cool.
run.
Let's run it again.
The
Six,
same.
right?
Yeah.
Very good. Okay, now can you change one of the plus to a minus?
Uh, yes.
Okay, let's run it. Let's see what happens.
Uh,
Okay, what's happening here?
Something about the order of operations. Mm.
Hmm. Okay. What does that mean?
Add. Hmm. Where should I add these parentheses? To group? I don't know.
Okay, so parentheses. So what it's saying is that the computer doesn't know, do you want to add first or do you want to subtract first?
Mm-hmm.
So let me ask you, do you want to add first or do you want to subtract first?
Let's say we want to add first.
Okay, we want to add first. So you want to do one plus two first.
Mm-hmm.
Okay, you need to surround one plus two in parentheses.
Mm-hmm.
Okay, now let's run it.
Okay. Then
Okay,
it's
great.
0.
Very good. Okay, so this is the idea of order of operations. The idea here is that there are many operations happening, addition and subtraction, and there's an order as to which should happen first, right?
Mm-hmm.
Now, in mathematics, in real life, are you familiar with BADMAS?
I don't know.
Okay, so there's a convention in mathematics as to which order, as to what the order of operations are. For example, that we should multiply before we add.
Oh, yeah, yeah, of course, of course.
Yeah, so yeah, there's a convention that does not exist in this programming language. Why doesn't it exist in this programming language? Well, in real life, there are about six rules for the order of operations,
Mm-hmm.
but in programming languages, there are more than six rules. There are a lot of operations, a lot of operators, and if you were to memorize a convention, there will be at least 20 rules. That's a lot to memorize.
Mm-hmm.
In some programming languages, they make you memorize it, and that's very painful.
Yeah.
This language is designed for beginners. They don't want you to feel a lot of pain. And so you don't have to memorize anything, but you must be specific. Like here, you have to add parentheses around 1 plus 2. Okay?
Yeah.
Okay, so yeah, this is the idea of order of operations. Great. Let's do something a little bit different. let's delete everything. Could you write two numbers separated by a comma?
Like this?
Oh, a comma. That's a full stop.
Yeah. Mm,
Yes, perfect. Can we
okay.
can we do two different numbers?
Of course.
Okay, now let's surround everything in parentheses.
Everything.
Yes. Now, before the first parentheses, could you write NUM?
M, what? M?
Sorry, N for like num. NUM, num.
Oh.
Yep. Dash. That's a slash. I mean, like a hyphen. That's a space.
What is a bash?
Oh, here, let me show you. It's this. It's like the
Oh,
minus
okay.
sign. Yeah.
Minus, okay.
Yeah,
But
perfect.
with
And
the
then
space.
without the space actually.
Okay.
So we're not so yeah, just minus sign and then MIN, min.
Here?
Yeah, after the minus sign, just write MIN.
And
Oh, M for Marvin.
MIN?
Yes, perfect. Okay. Before we run this, what do you think is going to happen?
Hmm. I don't know. I don't understand this.
So yeah, just give a guess. Just give a guess as to what might happen.
Something with these numbers. They will be, I don't know, just written besides each other.
Okay. All right, let's run it and let's see what we get.
Just one.
Just one. Why did we get one?
I don't know what happened with
Okay.
the three.
So I want you to change the numbers around, keep getting new answers, and figure out what this nummin is doing.
uh, it's somehow deleted everything after the comma.
Maybe. So I would like you to change the numbers and play around with it. Try to figure out what's happening. Okay.
And then run.
Yep.
Then it's one. Oh,
Hmm.
it's um, like mm, I don't know how to say. Mm, Number to the power of the number after the comma.
Well, if that's true, we would have gotten 8, right? 8 to the power of 1 is 8. But we got back 1.
Yeah. Sorry, it's logarithm. Something like this.
Well, if it's logarithm, we would have gotten 0, right?
Yeah.
So it can't be
Uh,
logarithm. Keep playing around with the numbers. Let's try new numbers. Okay, 10 and
I
8,
think
nice.
that's everything. And now it's 8.
Okay, we're getting 8. Okay.
So right now it doesn't make sense. Before, because the first time it was the first number and then it was the second number.
Hmm. So you're saying it's producing one of the two numbers.
Yeah. Oh, maybe which one is smaller?
Okay. Can you try one more example?
Uh, yes. Yes. Okay. I got it. So it
Yes.
tells us which is the smallest.
Exactly. Yeah. So the min actually stands for minimum. Gives you the minimum number.
Number minimum. Okay.
Yeah. Okay, very good. Okay, I'm going to clear everything again, and we're going to. So, just to summarize what has happened, we have worked with numbers and we have performed arithmetic on numbers. Oh, actually, wait, I
Mm-hmm.
want to bring that back. There's one more idea I want to show you. We've been doing arithmetic on numbers. We've been performing operations on numbers. Could you add this whole thing to another number?
So just add another here.
Oh no, add as in plus. Plus this whole thing with another number.
Like here?
Oh yeah, sure, let's do that. Let's run it.
Yeah, it's still okay.
This
It's
is still
still the
two, right?
smallest.
So you can add
Mhm.
numbers inside the parentheses. Now, can we move the plus 7 outside? Let's move the plus
Oh,
7 to the right of the parentheses.
so like this.
Yes, perfect. Let's run it.
Okay, so now it's 2 plus 7.
Yes. Okay, so again, with the idea of order of operations, right? There are two operations. We are getting the minimum and we're adding. Okay.
Mm-hmm.
When the plus 7 was inside the parentheses, the addition happens first. But when plus
Yes.
7's outside, the minimum happens first and then the addition, right?
Mm-hmm.
Okay. And the reason why the addition happens first when the plus was inside. So like, let me move the plus inside for you. When the plus is inside, um, in order to get the minimum, it needs two numbers. Okay, two. Oh, what's the second number? 9 plus 7. Oh, it's 16. It has to perform the addition first before it can actually find the minimum, right?
Mm-hmm.
Okay. So notice how we start using words as well for our operations. Just now we had plus and minus, but now we have words. In, well, in mathematics, there could exist an infinity of operations, but we only have so few symbols. So we have to start using words, right?
Mm-hmm.
Yeah. And the words, they're no different from plus or minus. Like you can mix and match them. The same way we can do plus and minus on one line, we can do plus and minimum on one line. Okay.
Yeah.
Great. Okay. So that's it for arithmetic. We're going to move forward in time a little bit. I'm going to introduce a new idea. And I know you know this idea because you did it just now. Could you write x equals 1?
What? Just one?
No, sorry, x equals 1.
Ah, okay.
Yeah. And
Uh,
on a new
okay.
line, let's write x.
Again, X?
Yes. So before we run this, what do you think is going to happen?
Mm, it will give me one.
Okay.
Like,
And why do you say it'll give you 1?
because no, maybe it will give us X, and somehow we have to ask what is behind the X to get the one. I don't know.
Okay.
Because we
Uh,
just name one the X factor, and I don't know what will happen.
okay, let's run it. Let's see. See that?
Okay, that's one.
We got a 1.
Mhm.
Okay. Can we change the x to x plus 1?
Mm, like here,
Yes. No, before we run it, what do you think we'll get?
two,
2. Okay. What do you say we'll get 2?
because it's just mathematics. Like I see now, it's just a calculator, and it should just add one to X, which is one.
Okay, very good. So yeah, if you run it, we get 2. So yeah, this is
Okay.
variable substitution. It's the idea
Mm-hmm.
that it's gonna, when it sees x, it sees 1. Because that's what we
Yeah.
define x as. Yeah, it's very good. Okay. Can we create an empty line between the two? So let's create a new empty line right after x equals 1. And can you write x equals 2?
Mm, uh, what?
Okay.
Okay, so
Very good. Before we run this, what do you think is going to happen?
an error
Okay. And why do you say it's an error?
because it's impossible for this for the X to be two different numbers at the same time.
Okay. Cool. Let's run it.
Yeah.
Yeah.
So this is an error.
So different programming languages will have different answers here. In Python, this would work. But here
Mhm.
it's an error. as you say, it does not make sense to define x twice. We
Mm-hmm.
say here we see the word, if you look at the error message, we say this declaration of a name conflicts with an earlier declaration of the same name. The word declaration, we declare x to be 1, and then we say, oh, we're declaring x to be 2 again, but why are we declaring it twice? The word declaration is like the declaration of independence. Once
Mm-hmm.
you declare it, right? You can declare independence again.
Yes.
Okay. All right. Very good. Let's try something different. Can we replace y equals 2? Sorry, change x equals 2 to y equals 2. And let's do x plus y instead.
Yeah, and that should work. Just 1 plus 2 equals 3. Yeah. Oh.
Very good. Okay. Can we try something? Can we move x plus y to above x equals 1?
Um, where? What should I change?
So let's take x plus y and let's move that. Let's cut it and move it above x equals 1.
Here?
Yeah.
Okay,
Oh,
it
wait,
should
sorry.
work the same.
Oh, yeah, it's the same thing, right? Yeah. Okay. Can we move x
Yeah.
plus y 1, like line 4? Can we move that above x equals 1? Just move that one line up.
Mm,
Okay.
okay.
Now, before we run this, what do you think is going to happen?
I think it should work. If this is the easiest uh, thing to learn, I think it should work in this program.
Okay, let's run it.
Oh no, it didn't work.
Ah, it's unbound. It is used but not previously defined, right? Because it hasn't been defined yet, right? This,
But the same is for the x.
yeah.
Just highlighted the y, not the x, but they are both above the equation.
So if you look at errors, there's actually two, right? It will say the name X is unbound, the name Y is
Oh,
unbound, and you
okay,
can click.
okay.
You can
Yeah,
click on the
there
boxes, by the
is.
way. You'll highlight the different letters.
Okay, so there is actually two bugs, and the equation
Yep.
should be under. Mm, okay.
Yeah, so there's a notion of time. The declaration of X and Y hasn't happened yet.
Mm-hmm.
Yeah. So it goes from top to bottom. And this is the idea of order of operations, but across multiple lines. It tries to do the addition before the declaration, so it doesn't work. Okay.
Mm-hmm.
All right. So what
Okay.
we have done is a bit of algebra. We have moved on from arithmetic and we've involved a bit of algebra by having variable substitutions. Okay.
Mm-hmm.
All right. Uh I'm gonna move on to a different idea. It's gonna look kind of funny. So I'm gonna clear it.
Of course.
I'm going so another key idea in algebra is functions. What is a function?
Uh, like the things like while, else, if, are these
Okay,
functions?
those are not functions. Those are something else, which we'll get to in the future.
Okay. So I
Okay,
don't know.
okay, it's okay. So first I'm going to, okay, so this is a comment.
Mm-hmm. I know
Oops.
this.
Okay, comment. Okay, so a comment, it's invisible to the programming language. I'm
Mm-hmm.
writing this just for you to see, not for the programming language to see. Have you seen this before?
Okay, these functions. Okay.
Like in mathematics?
Yeah, years ago, but yes.
Years ago, okay. Okay, so yes, we can also define functions in our programs, but it's going to look a bit different. Okay, on a new line, I would like you to write fun.
Mm-hmm. F, and what?
U.
Okay. Yeah. Uh, and
Okay,
and this should be some number. Yes.
Okay. Yeah, but it's gonna look very different from that. At the start of the line, before the F, I need you to write fun, F-U-N,
Mm,
space. Okay, notice how it's red in color.
yeah.
So we're
Why?
telling the programming language we want to create a function. That's what's happening.
Mm-hmm.
So f of y is correct. But we don't use equal sign here. We need to replace the equal sign with a colon.
Uh,
Yeah, but that's after that's replacing the equal sign.
oh, okay.
Yeah. Let's create a new line. Here, okay, what do you want to do with y plus one?
Um,
Yeah,
what?
sorry, I misspoke. What do you want to do with y?
Uh, hmm. Like I need the x plus one and something else.
Okay. Do you want to add one to y?
Mm. What should I do? How to add one?
Okay. How do we add numbers? Like what we did just now.
We just did one plus one.
Okay, so can we do that here?
Uh, but here in another new line
Yeah,
or
yeah.
like
Okay.
this?
Yeah, but let's use the y. Can we replace one of the one with a y?
Yeah. Okay.
Okay, great. Okay, now I want you to create on a new line. Can you write n? That's E and D.
E-
Oh
What?
no, sorry, on a new line.
Uh, what did I did?
Yeah.
Y N E?
Oh, sorry.
What?
Okay, I'll write it for you. I think it's not clear how I'm speaking. So E and D.
And and
And yeah.
okay.
Okay, notice how it's all highlighted when we wrote n.
Yes. Yes.
Okay, so what we have done is we have just defined a function.
Mm-hmm.
So it looks a bit different from what you're used to.
Yeah.
The space before the colon isn't necessary, so I'm going to delete that. So this is how we define a function in this language. If we hit run now, what happens?
Mm, I don't know.
Can you click run?
Uh, nothing. Nothing happens
Nothing.
because we
Okay,
don't
nothing
have
happened.
x. The x disappeared. So.
Yeah, because we didn't use this function. We just defined it, but we didn't use it, right?
Mm-hmm.
Okay, great. Um, okay, this Zoom session is going to expire. I'm going to have to send you a new link on Zoom. Okay.
Okay.
All right, you'll have to join on both your computer and your phone.
Yeah. Yeah.
Okay. All right, I'll see you in a minute.
Okay. Yeah. I see everything.
Okay, everything set up?
Yes, I see everything.
Perfect. Okay, so now we're going to use this function. So in mathematics, how do we use the function?
Uh, I forgot, but we need an x, and we just have to know just one variable. How which number is it? So we have to know either y or x.
Okay. All right. So in mathematics, we say we apply a function. In programming, we say we call a function. So on line
Mm-hmm.
7, can you write f, opening parentheses, any number? Perfect. All right, that's closing parentheses. Let's
Mm-hmm.
run it now. Let's see what happens.
It's yeah, it will be 21.
Okay,
Okay.
why did we get 21?
Uh, because the the function we called y was 20, and then we asked for, but I don't know why it happened, because before uh, it didn't worked when we had like the not knowing how much is some letter. and now it's under, but it calculated somehow.
Ah,
But
that's a good question, actually. So what's happening here is that when we say f of 20, we call f of 20,
yeah,
y takes on 20 at that moment.
okay.
It just
So,
happens. Y takes 20.
okay.
Yeah. So there's a notion of variable substitution happening here, right? On line 4, what is y? Oh, y is 20 because that's what we called it with. Okay.
Mm-hmm.
Now what happens if I do this? See what I've done there?
Yeah, that's
Now
what I
before
meant.
before I run this, what do you think will happen?
Like for me, it should be working like before, but okay, right now it don't know that this is the function y. Mm-hmm.
It doesn't know what f is, right?
Yeah, okay.
Because same thing like the
That's,
variable, it hasn't been defined yet.
mm-hmm.
Okay. I'm gonna move that back down. All right. So I need to do some explaining. So a function, so I just now ask, what is a function? Now, that's a function right in front of us. But what is it really? A function, so I'll write this down. Function is takes input and produces an output. Okay?
Mm-hmm.
So
Yeah,
another way of understanding it is function is input to output.
yeah.
Okay? So uh another thing is that it has a name and has a name so that you can refer to it. Okay?
Mm-hmm.
So there are three components: input, output, and name. Okay?
Mm-hmm.
So on line 6, we
Yes,
say that the
okay.
function name is f, right?
Mm-hmm.
That's why on line 10 we can refer to f. We gave it a name. Next thing a
And
function
then,
has is inputs. Line 6, y is the input, right?
yeah,
In programming, we call inputs the parameters. So we say y is a parameter, okay?
okay.
The final thing is the output, what the function produces. What is the output? What work is it doing to produce the output? Line 7, y plus 1, right?
Yeah.
We call this the body. The body of the function is what produces the output.
Mm-hmm.
And line 8 end just says it's the end of the body. The function is done.
Mm-hmm.
So we got name of function, we have the parameter, which is the input, and we have the body, which produces the output. Okay?
Yeah.
Then we can also call a function, and we pass in the number 20, and y will take on the value 20, and then 20 plus 1. Okay. All right, so we've explored algebra, we've solved variables, variable substitution, and now functions. Let's, okay, I'm gonna move on to a different idea. Let's pause
Mm-hmm.
all this, and I'm going to, okay, since this is on your computer, oh wait, no, this is not on your computer. Okay, I'm just gonna clear this all.
Yeah.
This is
I
this is
see
all recorded.
everything the same. Mm-hmm.
Okay, yeah, but if you want to review the recording, it will be on YouTube. It's just if you forget anything, you can review the notes. Okay, I'm now gonna go to a different idea.
Mm-hmm.
Um, it's a bit philosophical, so you gotta humor me. But I'm gonna write the number 5 here. I'm gonna run it.
Okay.
Now, what does this number mean? What does 5 mean?
Right now, it doesn't mean nothing.
Means nothing. Okay. Now, what if I say, what is 5 degrees Celsius?
That's a temperature.
Temperature, how hot, how cold something is. How about 5
Yeah.
kilograms?
Yeah, that's a weight.
Wait, okay, how heavy, how light something is. Now, they're all 5, but depending on whether I say degrees Celsius or kilograms, it means something a little different, right?
Mm-hmm.
Okay. So there are two worlds. There's the world of information. This is ideas and facts about the real world. And there's the world of data. That's what the computer sees. Now, you and me, we
Mhm.
say 5 degrees Celsius, but the computer, all it sees is the 5 right in front of us. All it sees is data. It does not know its temperature. Okay?
Mhm.
Now, it sounds philosophical, but it's a very practical idea. Our role as programmers is to convert information into data, perform operations on data, and convert that back into information.
Mhm. And how
Yeah,
do we do that?
like so everything that we'll do in our sessions is based on that principle, and we'll explore different ideas of doing that. But I'll give you one example. Like let's say we have an electronic thermostat, so that a thermostat that runs with a computer. There's information like the temperature in the real world. The thermostat is going to have physical sensors that measures readings about its natural environment, like the electrical resistance and whatnot. And then it's going to
Mhm.
convert all those readings into numbers. It's then going to perform mathematical operations on those numbers and deduce one final number. It's going to display that final number. We will see 5 degrees Celsius. The computer doesn't know its temperature. We do, but the computer only sees 5. Okay. All right. This sounds
Yeah.
very abstract, but I promise you it will make sense as we move forward.
Yeah, like we just have to name the thing that we need and
Exactly.
then call it the some number, mm, or calculations.
Exactly. Okay. We'll So to reframe everything we've done so far, all we have done is we have encoded. So I use the word encoded to mean we have turned information into
Mhm.
numbers. We've encoded information as numbers. Now, my
Yes.
question now is, can we encode all information as numbers?
Yes, I think.
Okay, why do you say that?
Mm, why not? I don't know. I think it's possible to name every information.
As numbers. Okay, you sounded
Yeah.
very confident. Surely you must have a reason as to why you said yes.
I don't know, like I think I can write anything and then uh I don't know.
Okay, you
And
are correct actually. Like you know how they say computers are a bunch of zeros and ones?
yes.
Well, zeros and ones, they're numbers, are they not?
Yeah.
So everything can be encoded as numbers.
Yeah. It's
Like
true.
even words can be numbers. Like Morse code.
Yes.
Yeah, like during the World War, the
Yes.
communication technology is very primitive. They had to use Morse code to communicate with each other, and Morse code is essentially zeros and ones.
Yeah. And that's coding.
Exactly. Yeah, that's literally encoding, right? Okay, so
Mm-hmm.
we can encode all information as numbers. Now, my next question is, do we want to?
Mm. Yeah, sometimes. Yes.
Okay, sometimes we want to sometimes, but do we want to every time?
Mm. Maybe not.
Maybe not. Why not?
Maybe sometimes we want words to change to other words, like the input and output would be different, but it would be just in words, not numbers.
Okay, why do we need words? Why not stick to numbers?
I don't know. Some purposes.
Okay, it's understandability, right? It's more understandable to read words.
Yeah.
For example, you and I were talking right now, but we're not talking in numbers. We're not talking in Morse code.
Yeah.
Like during the World War, when people use Morse code, you needed to have a room full of people decoding the Morse code because any one person could make a mistake, right?
Hmm.
The chances of a mistake is very high with Morse code. But like right now we are talking, and it's so easy. We're just using words,
Yes.
right? So words are more understandable. They're more efficient, right?
Mm-hmm.
Like humanity has existed for a very long time. And one of the first things that human civilization made is language, so that they could communicate with each other.
Yeah, and programming is just another languages to learn.
Exactly. Like we're not writing in zeros and ones. We're writing in a programming language
Mm-hmm.
because it's easier for us humans. So we don't want to encode all information as numbers sometimes. We want to encode them as something else. So I'm
Yeah.
going to show you a new way to encode information. Let's get back to
Yes.
programming. Can you write double quotes? Hello, comma space world.
Uh,
Closing double quotes. And let's run this.
okay. Yes, it
See that?
worked.
Hello world. We didn't get back a number. We got back a different animal. We got back a string, like a string of characters.
Mm-hmm.
So strings are used to encode words. This is now a new way of encoding information. We say that this is a new data type. When I say data type, I mean a classification of data. So numbers are a data type. Strings are a data type. Okay.
Mm-hmm.
So yes, we have a new. So this just now, everything we've been doing was like we could have done with a calculator, but this is the first time we have gone beyond a calculator. We are now working with a thing other than numbers.
Yeah.
This Hello World example is pretty historical. Back in
Mhm.
the 1970s, there's a guy, he's a very established programmer. Back then, there weren't many programmers in the 1970s. It was a fairly new field at the time. He wrote a book on how to program, and he used this example, Hello World. Ever
Mm-hmm.
since that day, every book, video, lecture uses this example, Hello World. It's like it's a rite of passage. Every beginner must write this, Hello World.
Mm-hmm.
So congratulations, you have just reached a very important milestone in your life. You
Yay.
can you can do something to celebrate later.
Okay.
All right. Now we have strings. Just now we have numbers and we can perform arithmetic on numbers. Can we perform arithmetic on strings? Can we add a string to another string?
Yeah, I think that's possible.
Okay, let's do it. Can you show me how we can add two strings?
Like this. Um, and what should I write? Hello. Mm, I don't know.
Okay, very good. All right, let's run it.
Okay, but it doesn't have any space.
Now, if you want to add a space, how would you do it?
Hmm. I saw in Python some tricks, but in this, I don't know. Here
Wait,
it
what
should be seen
tricks?
here. Like, what was that? Uh, like I don't know, some free letter shortcut, uh, and then I added like space, something like this, or oh, it didn't work.
Oh,
Or
if you want to
maybe
do this, okay,
like
yes, exactly, yeah. Oh, you have to add a space though to the plus.
uh
Yeah.
okay, it worked.
Yeah, it's
Okay.
perfect. Yeah, yeah, no,
I
exactly. Yeah, the
figured
same
it
way we
out.
can. It's like just now, right? Just now we added two numbers and then we added a third number.
Mm-hmm.
Okay. Now, can we replace one of the plus signs with a minus?
Um, hmm.
Remember
Yeah,
order of
it
operations?
yeah. So something should be uh in this. Yes? No,
Well,
it's
remember a
different
minus
color.
must. You need two numbers. Sorry, you need two things on each side of an operation, right?
Okay, this. This? No,
Yes. Let's run it. Ah.
no.
Oh, wait. It's missing the closing quotation marks on Anna.
Oh,
Sorry, Anna. Yes.
yeah. It's always something missing. Still
There you go.
something.
Ah, so what does it say?
Mm, left side, right side. It doesn't have anything to. Uh, I don't know.
What does the final line say? The final line of the error message.
Mm. Like it expected to have numbers, yes. So like you can't make calculations on words.
Hmm. We cannot subtract two strings. We can only subtract two numbers.
Yeah.
So what this means is that even though there is a notion of arithmetic for strings, it is fundamentally different from arithmetic on numbers, right?
Mm-hmm.
Okay. All right, let's
So we
pause
can
here.
add, but
Mhm.
we can't abstract. Okay.
Exactly. Okay, let's pause here. We are running out of time. Um,
Yeah.
yeah, we lost some time due to technical difficulties. That's okay. Uh, for this week only, I do allow you all to book another. So I usually limit once per week, but this week, especially on this week, I don't have a lot of sessions. So if you like, you can book another session, but you can only book it within 48 hours of that session.
Mm-hmm. Yeah, I've
So,
read that.
okay, yeah. So like, if you like to, you can do that. Um, okay, I like to end my sessions with my students by asking them, what is one thing you learned today that stuck with you?
I think the order of doing mathematics that and the function uh, that allows me to name to I don't know how to say this, but these few examples I've learned a lot, and I will keep practicing this on the different numbers.
Excellent. Cool. Okay. Yeah, there's a lot more to cover. I'm glad to be able to help you on your journey to learning programming, and I'm glad you learned something today. And I hope to see you again.
Thank you very much for the
Of
time.
course. Of course. Bye bye now.
Bye bye.